so in part 2 of tonight's lecture, we'll be talking about alcohols, ethers, and epoxides. So you should know by now that the alcohol functional group, from looking at your functional group sheet, looks like this. Remember that that R is just any carbon skeleton, and so our functional group is really the OH group. There are a couple of different classifications of alcohols. There is the primary alcohols. There are the primary alcohols. The secondary alcohols. And the tertiary alcohols. Primary, secondary, tertiary, etc. Okay, so a primary alcohol, all that means is that the carbon that the alcohol group is connected to has only one carbon bond. This R group here is the only carbon bond that this carbon itself has. So in other words, a primary alcohol means that your alcohol group is at the end of a compound. That would look like that. That's a primary alcohol. A secondary alcohol, you can probably guess, means that there are two R groups on the carbon that has the alcohol group. So in other words, you're talking about an OH being somewhere in the middle of a carbon chain. And a tertiary alcohol means that you have the carbon that has the alcohol group is surrounded by all other carbon bonds. Here's an example of a tertiary alcohol. This carbon here has 1, 2, 3 carbon-carbon bonds. In other words, a tertiary alcohol has, this carbon has no hydrogen bonds. Those are the classifications of alcohols. Let's talk now a little bit about how to name alcohols. We're going to follow basically the same procedure that we did for alkenes and alkynes. But now we have to do a little something special to treat that OH differently. Okay, so again we're going to start out by identifying our longest carbon chain. And now when we do that, what we're going to do is, let's say that we have a heptane. This step tells us to remove the E from the suffix and add OL. So I'm going to take this E off and write heptanol. OL is what signifies that you have an alcohol functional group. OL in the name is what signifies that you have an alcohol functional group. Okay, then what we have to do is to number the OH carbon by using a number in front of the parent name. Something like this, where you have 2-heptanol. That 2 is signifying that you have an alcohol group on the 2 carbon. So we're going to do this just the same way that we numbered for alkenes and alkynes. And now the next thing that's different is that in step 2 we have to number the carbons so that the OH group has what's called priority. In order to have priority, it just means you have to have the lowest number. So in this case, OH is always going to have the priority, even over other substituents or multiple bonds. Okay, so let's do some examples of this from your homework so you can get used to this a little bit. Okay, so start out by identifying the longest carbon chain. 1, 2, 3, 4, 5. That is pent. So you can just write pentane. Then you're going to take off that E and replace that with OL. So you'll have pentanol. And now you have to number so that that OH has the smallest number. Well, it's right in the middle, so either way you number, it'll always have that 3. This compound has no substituents, so your compound is just called 3-pentanol. Okay, here's a nice looking tricky one. Identify your longest carbon chain. This is not a butanol. This is a hexanol. And now there's that OH group is on the 2 carbon. And then here we have a substituent, we have a 3-methyl. That methyl group is on the 3 carbon. So this name is 3-methyl-2-hexanol. Here's one you can do for practice. If you're not getting this answer, you should go back and review part 1 of this lecture so that you can get practice with the 5-step process. All you're doing that's different here is plopping that OL at the end. That's the only thing that's different. Ah, here's another one. Ooh, I made a mistake. This is not your last carbon. Your longest carbon chain is not 7, it's 8. So you should have 6-methyl, 3-octanol, 3-methyl, 6-methyl, 3-octanol. Always got to watch out for that longest carbon chain. I even tricked myself. Okay, now that, if you're still having a little bit of confusion about that, you might want to work some of those alcohol naming problems on your homework and just check to see if you're doing that properly. If you need to rewatch the first part of this part of the lecture, I would go ahead and do that right away before moving on. Okay, ethers. Ethers are an interesting functional group. They are basically where you have an oxygen in the middle of a carbon chain. There are 2 different classifications of ethers. There are symmetrical ethers, and then there are asymmetrical ethers. And the difference is that for a symmetrical ether, you have the exact same carbon group on either sides of the oxygen. So if this is your oxygen, a symmetrical ether has exactly the same substituents on either side of the oxygen. Asymmetrical ethers do not. So that's what an asymmetrical ether could look like. Ethers are often talked about with alcohols in their reactions because they're almost the same as alcohols, except that in an alcohol, your oxygen, while it has 2 single bonds, one of them is connected to a hydrogen. And in ethers, we have one of those other bonds connected to another carbon. So that's the only difference between ethers and alcohols. Now I did just want to mention epoxides because they're a special kind of ether. In epoxides, you'll notice that here you have the oxygen that's in the middle of, this is a typical ether. Here you have that oxygen in between 2 carbons, and those carbons have other carbons attached to them. And in the epoxide, here, both of the R groups are actually connected to each other. So they form what's called, this is called a heterocycle. You should write this name down. A I'm sure this comes up somewhere in something. Heterocycle means that you have a ring, but it's not a ring of all the same members. So whereas you have your cyclohexane here, if you were to swap one of these atoms of carbon and put an O there, that would be called a heterocycle, because you don't have all the same kind of atom in the ring. Okay, so let's talk about some interesting types of these compounds. There are a lot of different interesting alcohols. The first one that I will bring up is ethanol, and you'll commonly see ethanol abbreviated ET, which is the common abbreviation for ethyl, and then OH, which is the alcohol abbreviation. So ETOH is what you'll commonly see for alcohol. Ethanol is the alcohol in booze. I think that we've already talked about this. So this is the alcohol that will make you drunk. It's also used as an additive in fuels. Now, I just want to talk about this a little bit because we were just talking in part one about alkanes and their purpose as a fuel. Let's talk a little bit about this. Again, in terms of alcohols and fuels. Okay, so this is that propane molecule that we were talking about before. We know that that's a fuel for stuff. And here is the formula. Propane is not what you use in your gas tank though. I'm not going to draw out an 8 carbon chain for your gasoline. So here is ethanol. CH3CH2OH. Now, remember what I said, every carbon-hydrogen and carbon-carbon bond, when it's broken, releases energy. So ethanol has a power to produce energy at 1, 2, 3, 4, 5, 6 bonds. Now, the trouble with ethanol used as a fuel is that when the compound itself is broken down, this functional group here, this alcohol group, breaks off from the rest of its parent molecule because all of these bonds are being broken. You're burning the fuel. And when this happens, this is going to combine with other things in your engine and it produces water. Now, this can be very serious for engines that are not capable of taking care of the water that's produced inside the engine. This isn't water that's being released into the environment. You're talking about internal combustion. So that means your burning is happening within the engine itself. So this byproduct is then left in your engine. There are a lot of engines these days, usually they say, I know like the GM cars say flex fuel compatible or E85 compatible. That means that some part of the engine has been specially manufactured in order to dispel the water that's produced from this reaction. Most older cars do not have this function, and neither do small engines like lawnmowers, snow blowers, ATVs, snowmobiles, any of those really quite a bit smaller engines than we're talking like car engines. So when water is produced inside an internal combustion engine, and that an engine is not properly equipped with the machinery to get rid of it, you can get knocking in your engine, which will destroy the engine over time. So because there are ethanol mandates in our state and in most other states, it's become harder to find gasoline that doesn't have ethanol. And a lot of folks are realizing now that perhaps maybe when they gas up their lawnmower or their snowblower, they shouldn't be using gas that has a high concentration of ethanol. You shouldn't use E85 ever in your lawnmower or your snowblower. So the thing about ethanol is it's a great fuel because you're able to produce it from corn and it's easy to produce. It does take a little bit of fossil fuel energy, however, to make ethanol, so that is a little bit of a concern, but it's not, you know, it's easy to produce from corn, when we grow corn. The only trouble about ethanol is that it's not nearly as efficient as gasoline is, on account of it only has 6 bonds that are broken in the molecule to create energy, and therefore you're not going to get as far on a tank of gas or a gallon of gas, depending on how much ethanol it has in it. And recently, with fuel prices the way they are, it hasn't brought the price of gas down real much. So that is what ethanol is used for as a fuel. There are a whole bunch of other, we're not ready for that. There are a whole bunch of other interesting alcohols. The methanol is known as wood alcohol. It's extremely toxic, and typically back during Prohibition, when folks were making moonshine, this is the alcohol they produced. It's extremely toxic, and while you only need about, the average person only needs about 25 milliliters of pure ethanol to go into a coma, for methanol it's like closer to 5 to 10 milliliters. So it's really dangerous stuff. If you happen to have methanol poisoning, when you go to the hospital, they will usually give you ethanol, which is, you know, the booze alcohol, because that stops the production of formaldehyde in your system. We'll talk about that a little bit when we get to biochemistry. There's 2-propanol. 2-propanol looks like this. 2-propanol is also known as isopropyl alcohol. That's rubbing alcohol. So this is the stuff that you likely have in your bathroom cupboards. It's also usually what is used in those little alcohol packets that you guys use to swab an area before an injection or before drawing blood or what have you. And then one of my favorite alcohols of all time is ethylene glycol. Ethylene glycol is interesting because it's actually what we call a diol. Di meaning 2, OL, all meaning alcohol, 2 alcohol groups. This is ethylene glycol. Ethylene glycol is used as an antifreeze, and it's also actually used, it's toxic, but it has a really, really sweet flavor. So it's used in a lot of really processed foods that are sweet. There are a lot of ice creams that actually contain ethylene glycol, and if you, depending on how much percentage of an ingredient is actually in a food, you can get away with not writing that ingredient on your ingredient list. So there are a lot of ice creams out on the market that actually have ethylene glycol in them. Very small quantities. You actually will not die from ethylene glycol toxicity from eating ice cream, unless you would probably have to eat a whole gallon tub on your own in one sitting, if it actually does contain ethylene glycol. But you'll never see that on the ingredient list, because it makes up such a small percentage. It's just so super sweet, and that's why they use it to flavor that ice cream. If you happen to ever spill ethylene glycol in your garage and you have a pet, you have to make sure that you really clean that up, because your pet will really like the taste of it. It's really sweet. And your dog or your cat or whatever, they'll die from ethylene glycol toxicity, because they'll just keep eating it. It's very tasty, but also obviously deadly. Okay, there's one interesting ether that you might want to be aware of. It's called diethyl ether, and it looks like this. Here's your oxygen in the middle, and it just has it has 2 ethyl groups. So 2 carbons here, 2 carbons here. This is diethyl ether. This is the anesthetic that was used in the early part of the 19th century in medicine. This is the ether that Curious George passed out from partaking of. Diethyl ether, anesthetic. And then there are 2 interesting epoxides. I'll put this up on Jewel, this picture, in a little while. I wanted to show you these pictures of what these molecules look like. Here we have periplanone. This is the cockroach sex pheromone, and hopefully you'll be able to see this. There are actually 2 epoxide groups. Oh, I can't use the, oh yeah, that's because I'm using the docking camera. My bad. Okay, so there are 2 different epoxide groups in this compound. One is right here, and the other is right here. There's also a ketone, an alkene, and that's just some other different stuff. That's a pretty interesting looking compound with 2 epoxide groups. Here we have another compound. This is an anti-cancer drug. This has a ton of functional groups. Here you have an alcohol, a ketone, an alcohol, ketone. Well, this is actually carboxylic acid derivative. And here is your epoxide. This part of the molecule is the epoxide. Having all of these functional groups is good because that means that you can have reactions at all of these functional group sites. And it can do a whole bunch of different stuff. Okay, that's all we have for this part.